All right. Welcome to this AMC 8 math enrichment program. So today we're going to together go through some AMC 8 level problems, and some of them are easier. I hope that even for easier problems, you can try to think about different ways to solve the same problem, and then you can compare which way is the most efficient. Because the more this type of practice you do, the better you become. And when it comes to the exam or test, right? So when you see a similar problem, then you can immediately identify the fastest route, and that will save you time. Because in this type of exams or competition, timing is very important. You for AMC, you only have 40 minutes, and there are 25 problems. And so you basically only have like 1 to 2 minutes for each problem. Um, and for some of the problems here, we're teaching you like how to find answers in like 30 seconds. So that hopefully will be very helpful. So let's take a look at a couple of these questions that some of you already started thinking about. So let's start with problem number 5. Okay. Those of you who have already thought about it, could you type your answer in the chat so we would know that you've done it? Jaden, are you there? Aaron and Shasha, what's your name? The name of your child?
Ellie，
Addie.
嗯，
Oh, okay. Addie, could you try to solve this problem?
你叫别的孩子吧，不好意思。
Oh yeah, yeah. No, you don't have to like talk to me. I mean, you can solve it
嗯
by yourself. As
I will.
long as she's thinking, that's fine. Yeah.
Okay, thank you.
Mm. And then for those of you who already finished number 5, you can move on to number 10. All right, so let's take a look at this problem together, okay? So a normal way of doing this is to say, okay, we have 60 teams, and each time a team lost will be eliminated. So we start from 60, right? And then if two teams pair up, so there are 30 games. So we eliminate 30 teams, right? And then from 30 to 15, right? So through 15 games, we're left with 15. And now this is the tricky part, right? Because um, 15 divided by 2 is not an integer. So that means we can have 14, so we have 7 games, and then there's a standalone, right? And that reduces it to 8. And then from 8, we can have 4 games, and that eliminated 4, so we have 4 remaining, and 2 games, we have 2 remaining, and 1 game, we have 1. Okay? So the total number of games needed is 30 plus 15 plus 7 plus 4 plus 2 plus 1. And what is that? So you can calculate the 3, 3 plus 7 is 10, 10 plus 4, 14, 14 plus 15 is 29. So we have 59. Okay. So that's one way of doing it. I hope you get it right. But wait a minute. Um, is there any faster way? Okay, Addie, do you understand this method? Um, oh, Shasha, do you think maybe she could like have camera on so we can, interact better? Otherwise, I don't know whether you understand it or not. Are you there? It would help for me to know whether this is too fast or this is okay speed. Like, if you understand it.
Sorry, you can keep going. Thank you.
Oh, okay. But does she understand it?
I'm not sure, but she's trying. Yeah, you can keep going. Thank you.
Oh, okay. So this way, basically, we're doing it the forward way, okay? Meaning, so based on the description, so we have 60 teams competing, so we know that we can pair them up. So we have 30 games, right? Each game have 2 teams, and then the loser will be eliminated. So that means after 30 games, we reduce to 30 teams, right? And then from here, we can have 15 games. So 15 will be eliminated. We have 15 remaining. And then from 15 teams, now we can only pair up 7 games, right? There's one team that doesn't have any opponent. So after 7 games, 7 teams are eliminated. We have 8 remaining. Does that make sense? And so we keep doing that until we have one team that remains, and that is the final winner. So to calculate how many games will be needed, we calculate each time how many games do we need, and then we add them up, and that gives us 59. So that's the forward way of thinking. Now, is there any faster way? Well, if we think of it from another angle, so after each game, one team is eliminated, right? Now, starting from 60 teams until there is a final winner, right? So how many teams need to be eliminated in order for just one team to remain? Well, that's just 60 minus 1, right? So 59 teams need to be eliminated. Now, for each game, right? Each game, how many team will be eliminated? Just one. So we need to eliminate 59 teams. How many games do we need to eliminate 59 teams? We just need 59 games, right? So this problem boils down to what is 60 minus 1, okay? And that's how you can solve this AMC 8 problem in seconds. If you see through this whole thing, it's just asking what is 60 minus 1. And of course, it's 59. Does that make sense to you? Okay. So you see that there are different ways of looking at the same problem, right? There's you know, a rigorous way, but it's tedious and it's easy to make mistakes. So if you mess up one of them, then the final answer could be mistaken. Whereas this is a very clean way, right? We think out of the box. We look at it from, you know, like it's like bird's eye view, right? We look at it, we see through the essence of the problem. We get to the very bottom of the problem. Okay, now let's do number 10. So number 10 says Alex helped a neighbor 1.5 hours on Monday, 90 minutes on Tuesday, and from this to that on Wednesday, and 10 minutes on Friday. And he's paid $11 per hour. How much did he earn for the week? Now, the normal way of doing this is to say, okay, so we know the hourly rate, right? He get paid $11 an hour. And so now we just need to know how many hours did he worked, right? So he worked 1.5 hours on Monday, and 90 minutes is another 1.5 hours. And then on Wednesday, it's starting from 5:20 to 9:10, so that's a little less than 4 hours. So it's, 10 minutes less than 4 hours, right? 3 hours, 50 minutes. But then on Friday, there's another 10 minutes. So those add up to 4 hours. And this times 11 is the final answer. So what is that? So 1.5, 1.5 is 3, 3 plus 4 is 7, 7 times 11 is 7, 11. No, it's 77. Okay, so 77. All right, so this is doing it the right way, the forward way. Okay, now, is there any way to solve this faster? So again, if there are any questions, if this is too fast, please feel free to interrupt, to say, oh, can you explain this again? Or, like which part you don't understand. Feel free to, just unmute yourself, okay? Um, because I'm here to help you, okay? So that's my responsibility to help you and make sure you understand it. Um, and it's your responsibility to ask questions, okay? Don't assume that you understand everything, unless you actually understand it. Okay, now what's a perhaps better way, a faster way? Let me erase all these. Okay, so given that this is multiple choice, right? Um, and AMC 8 is all multiple choice. So there are specific techniques that works for multiple choices. Um, for example, we can eliminate some answers that apparently, you know, not the right answer. So for this problem, well, the key is here. So he's paid 11 per hour. So that means, the total amount should be the number of hours times 11, right? So that means the answer should have a factor of 11, right? Now, if we look at all the answers, which one or which ones um have the factor of 11? Well, there's only one choice. See? That's how you can solve it in seconds. You don't need to list out all those complicated results. Okay? In fact, if you master this, like you only need to pay attention to this. Like I don't even need to read this. Well, I can do it later when I double check the answer. But, given this, that's the answer. Seconds. Okay? Kill in seconds. That's what we call the kiss. The teacher Ming called it kiss, right? All right. Any questions? All right. Let's move on to some other problem. I'll let you read it and think about it. Well, this one is not too challenging. So the regular way is to say, okay, 24, oh, sorry, 24 centimeter length represents 144. So per centimeter length is this. And so this should be equal to, this is what we look for, right? How many kilometers represent 34? And then you can do the division, right? This is, you find out 6. And so what we look for is 6 times 34. And you can calculate it, okay? So it turns out to be 204. And that's B, okay? Now, what's the faster way? Um, so if we think about it, so this is basically saying 24 centimeter represents this, and then they're proportional, right? So if we just think about, how much larger is 34 over 24? So this is about, it's close to a little smaller than 36 over 24, which is 1.5, right? And therefore, this should be slightly smaller than 144 times 1.5. Okay? And now, so that means it's close to, like 15 times 15. Can you see that? Because this is close to or smaller than, let me write down slowly. So this 150 times 1.5. And this is equal to 15. So 0 with, this is 10, right? This is basically 15 times 10. And then you can do 10 times 15. 10 times 1.5 is 15. So it's 15 squared. What is 15 squared? Well, 15 squared is 225. Do you know that? So either you memorize it or you can use the trick that when we have a repeating number here and these two add up to 10, then what you can do is this is 1 plus 1. So the repeating number plus 1 times the repeating number. So this is 2 times 1 is 2. And then 5 times 5 is 25. Okay? This trick is very powerful. Like, for example, what is 45 times 45? So you can do repeating number plus 1, 5. 4 plus 1, 5. 5 times 4 is 20. And then you put 25. Okay. So that basically means the answer should be slightly smaller than 225. Now, which one is slightly smaller than 225? Then that must be this, right? Others are either too small or too large. Okay. So use the fact that it's multiple choice, so we don't need to be very, very precise. Then we can quickly rule out some answers, and we don't even need to go into these calculations. So we can use, things that we are very familiar with to help us quickly get the answer. Okay. And this, I mean, at the closer estimate would be 14 times 1, 15. Okay. If you know how to do you know how to do this mentally? Ali, do you know? So 10-ish times 10-ish, we take the first number and then we take the unit digits 5. That adds up to 19 and put a 0 at the end. And then you do 4 times 5 is 20. And that's 210. So this is equal to 210. Okay. And which number is very close to this? And of course, this 204. And we have a class about these mental math tricks. If you're interested, I can also show you that. Yeah, we did it earlier this afternoon. All right. We good? Okay. Next, let's take a look at this problem. Okay. So Alex, Bob, Kathy, Danny, and Emily and Frank are chosen for the team to participate in the annual 4-person team basketball tournament. In how many ways can the 4 starters be chosen? So as you probably noticed, AMC 8 problems. In terms of the names, it always starts with A, B, C, D, E, F. Okay. And so this is basically choosing, 4 people out of 6. How many different ways? So if you have learned about permutations and combinations, then you should immediately know how to do this. Like it's just C, you choose 4 out of 6. Okay, that's one way of doing it. And this, according to definition, is 6 times 5 times 4 times 3 divided by 4 factorial. You know the factorial, right? Factorial basically means 4 times 3 times 2 times 1. Okay? It's the same. So 4 times 3 will cancel with that. So it's 30 divided by 2. So that's 15. So that is if you know about combinations. Now, if you don't know that, there's still a way to do it. So basically, we want to fill these four positions, right? So we want to choose four people for the tournament. Now, um, does the order matter? The order among the four people, does it matter? It doesn't matter because, as long as we have four people, they can form a four-person team, right? And do the tournament, participate in the tournament. Now, um, so it boils down to how many ways can we fill those four positions where the order doesn't matter. Now, when the order does matter, okay, so for the first position, how many choices do we have? Well, for the first position, we can choose from any of them, right? So there are six choices. And now, let's say we choose Bob for the first position, then we only have five people left for a possible second position. So there are five possible ways to fill the second position. Now, when the first two positions are chosen, so two people are gone. So for the third position, we only have four choices left. And once we choose three, there are only three people left to choose from. Okay? So this is basically what we call the permutation. Um, this is when the orders does matter. So meaning we choose Bob in the first place and Alex in the second place will be different from Alex in the first place and Bob in the second place. Um, but in this problem, the order doesn't matter. So as long as they are in the team, it's the same. So these two are the same, okay, to us. And um, in fact, there are multiple ways to do that. Like for example, if we choose um Alex, Bob, Danny, and Frank, okay? So um versus if we choose Bob, Alex, Danny, and Frank, that's the same, okay? And if we choose, you know, Bob, Danny, Alex, and Frank, that's also the same. But within here, they're different. So given these four people, how many different ways can we arrange them? Well, for the first position, we have four ways, right? We can choose any of them. And the second position, once this is gone, we have three ways. And once they are gone, we have two ways. And the last is one way. So given the choice of four people, we have this many ways to, change the order. But all of them, um, within this, they're the same. They're counted as the same. So that means we need to divide this permutation by 3 times 2, 4 times 3 times 2 times 1. Okay, that's the combination that we look for. And you do this calculation, is also 15. Okay. And another way of thinking about it is, so choosing four people to form a team is equivalent to choosing two people to be not included. Okay. So maybe that would be faster to do. Choose two people out of six. But in this example, it should be the same. Okay. So C62 is 6 times 5 divided 2. Okay. Are there any questions? Okay. All right, let's move on to this problem. This problem is longer. Okay, I'll let you read through the problem and then we'll talk about it. Okay, so how do we tackle this problem? All right, so here we know that when the cell phone is not on, sorry, when cell phone is on, but she's not using it, so battery lasts for 120 hours. And if you use it constantly, then battery will last much shorter, like 15 hours. Um, Now, basically we can think of it as, the battery life, right, is 120 hours, when it's just on, but not using. Now, when she's using it, like texting or, watching videos, then the battery life would be 15 hours. That means when it's being used, for each hour of using, how many like regular hours does it um consume? So this is basically saying it's 8 times faster. Can you see that? Because 120 divided by 15 is 8. So that means when it's being used each hour, it will consume, 8 hours of, you know, just idling. So this is called idling hours. Okay. So that means if you're not using it, right, it can last for 120 hours. Now, um, when it's being used, each hour is using 8 hours of idling hours. Now, since the last chart recharge, the phone has been on for 45 hours, and during which time she had used it for 4 hours. That means out of the 45, right, there's 41 hours that she's just using the idling hours. And then there are 4 hours she's actually using it. So that means during that 4 hours, that's how much idling hours she has used, right? Now, the question is, if she doesn't talk anymore but leave the phone on, how many more hours will the battery last? So it's basically asking how many more idling hours there is left. So it's basically, so this is what the idling hours that's been consumed times, 4 hours of active using times 8 idling hours per unit hour. And then total is 120 minus that is what's left, right? So it's basically, this is, okay, so 41 plus 32 is 73, and then 120 minus that is 47. So the choice is B. Okay. Are there any questions? Now, if you have learned about fractions, then you can also do it that way. But I think this is pretty clean way of doing it. Mm-hmm. Yeah. So in other words, if we rethink about it, so how many hours? So basically, how many idling hours do we have left? So we can think about it. Out of this, so in total we have, at the full recharge we have 120 hours. And then out of that, there's 41 hours of not using it. And then there's 4 hours, but at a 8 times speed rate, right? So that's the same. Okay. So I hope that you get the idea. So how to get to the bottom of the problem. Okay. Alrighty. Let's move on to the next problem. Okay. This is like a logic reasoning problem. I'll let you read through it and then we'll look at it together. Right. Let's look at this problem together. Like Alex, Bob, and Kathy are friends with different ages. Exactly one of the following statements is true. So that immediately tells us that um only one of them is true and the other should be false. Okay, so let's start by assuming the first is true. Okay. Hi, Yuqing. Welcome. All right, we're trying to tackle this AMC 8 problem. So let's assume the first statement is true. Then Bob is the oldest. So that would tell us, this. And now, if this is true, then the second and third must be false. So if the second is false, that means Alex should be the oldest, right? If this is false. But then number one says Bob is the oldest, so these are in conflict. All right. So that means the first cannot be true, right? So we don't need to consider this. Now, the first must be false. Now, if the second is true, then Alex is the oldest. So that would give us these two choices. And then, um, and the third must be false. So Kathy is not the youngest. So Kathy is the youngest, so this cannot be true. And now let's check if this is consistent with the first one. So first statement, Bob is the oldest, is not true. Is not true. So this seems to be consistent with all of them. Okay. Now, let's think about another possibility. Oh, so usually you can already end here, but let's just say, what if this is true? Okay. If Kathy is the youngest, I mean, is this true? Is Kathy is not the youngest? Kathy is not the youngest, that means we need to exclude the um I'm sorry, is not the youngest. If this is true, Kathy is not the youngest, so that means um yeah, D needs to be included. And then this must be false. So Bob is not the oldest. And then Alex, this will be false. So Alex must be oldest. So that would give us um wait, hold on. Did I make a mistake? So Alex is not the oldest is false. So Alex must be oldest. Sorry. I think I might have. But let's see. Alex is the oldest. Uh, and then Bob is not the youngest, so this cannot be true. Um, and then Kathy is not the youngest. Um, so let's start from here again. So Alex is not the oldest, is four, so Alex is the oldest. There are two choices. And Bob is the oldest is not true. And then Kathy is not the youngest. So in this case, Kathy is the youngest. Um, so this cannot be true. So this one, let's check. Okay. For the first, Bob is not the oldest. Okay. So the first statement is false. And then second statement, Alex is not the oldest. And that is false. And then Cassie is not the youngest. Um, Cassie is not young. So this is correct. Okay. So it satisfies all of them. Okay. All right. Let's move on to the next one. Okay, so let's look at this problem together, okay? So there are different ways to solve this, and one way is to say, okay, so the area, okay, so let's calculate this area first, and then minus 1, right? Because the whole need to be excluded. So let's calculate this irregular polygon first. Now, this area, we can do the bigger area, which is this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 10? 1, yeah. Plus 10 times 1, 2, 3, 4, 5. So it's 10 by 10, right? Total is 10 by 10. And then you subtract this, that, and that. Now, um, to make it easier, let's do this. So you subtract this part and this triangle, and then so 4 triangles. So let's start from this triangle. So it's 1, 2, 3, 4, 5. So 5 by 1, 2, 3, 4, 5. Oh, sorry, 1, 2, 3, 4. This is 4. So 5 times 4 divided by 2. That's the area. Okay. And then here you have 6. So it's 6 times 10. 6 times 10 divided by 2. Okay. Oh, sorry. And minus that. And then minus this part is 7 times this is 1, 2, 3, 4, 5, 6. So 7 times 6 divided by 2. Now, the last part, one side is 7. Sorry, one side is 6, and then one side is 5, right? So it's 5 plus 6 times the height is 3 divided by 2. So if you calculate this, so this is 5 times 4 is 10, then this is 30, and this is 21, and this is 11 times 3 divided by 2. So it's 33 divided by 2 is 16.5, okay? And you calculate that. So this is 100 minus 40, it's 60. 60 minus 21 is 39. Wait, did I miss? Um, and 39 minus that is 23.5. Did I mess up anywhere? 7, 5 plus 6 plus, that is correct. And 7 times 6 divided by 2 is 21. I might have messed up somewhere. But that's the point is, it's very easy to mess up with this method. And then after this you subtract one of them from it. Um I might have made a mistake somewhere. This is 42 divided by 2 is 21. 21. Oh, this is, yeah. Yeah. This is 22.5. Yeah, that's correct. So 39 minus 61.5 is, oh, I'm sorry, 16.5 is 2, 2. So it's 22, yeah. And so the final area should be this minus 1, minus this whole. So it's 21.5, yeah. So so the answer is C, okay? So that's one way of doing it. Now, what's a faster way? Well, so do you know about this pig theory? So pig theory is saying the total area is I half B minus 1. What does that mean? So I means the interior. How many interior points are there? And B means the boundary point. So if we take this as an example, so we can calculate. So boundary points, so 1, 2, 3, here. You cannot miss this one. 4, 5. So 5, B is 5. Okay. And interior, so we can count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's 21. So the area is 21 plus 5 divided by 2 minus 1. And that is 25. It's 2.5. So it's 23.5 minus 1 is 22.5. Okay. So that is the total area of this. And now we need to subtract minus 1 is 21.5. Okay. So that's a faster way of doing it, is just by counting the interior points and the boundary points and use this equation. I have B minus 1. Okay. And is any faster method? Okay. So given this is a multiple choice, and uh, let's think about it. Right. So usually, okay, so for deceiving us, right, there usually should be two numbers that differ by 1 because, we need to subtract a whole from it, right? So there should be two answers. One of them is correct and the other is, you know, one smaller than it. Okay? So by that way of thinking, there are only two choices. Now, which one should we choose from? Well, we know that the correct answer should be one less than the deceiving one, right? So that means it must be C. Okay? So that's how you can kill in seconds. Like even without going through all these or the previous calculation, right? But of course, it helps to learn these methods. So I emphasize, if you know multiple ways to solve the same problem, it first, it broadens your perspectives. And second, in the future, like, which one is the fastest. And you can quickly identify the way to um, choose the right answer. Okay, so are there any questions? That wraps up the class today. And if you're interested in learning more about AMC 8 classes or the pre-AMC mental math, yeah, we have other um, classes scheduled. So, all right, we're good. Thank you all for your attention, and hope you'll enjoy the rest of the weekend. All right, bye everyone.
Thank you, Chris. Bye.